My dear, so in this video tutorial you are going to learn about all theories of failure. I hope you are going to enjoy this tutorial, and because I am going to discuss all theories of failure, that's why this tutorial would be a little bit lengthy. Okay, so what we are going to discuss today: theories of failure. So probably I don't know, see which level you are right now. You are beginner, or maybe you are advanced, or maybe you are just starting out. So I will start from beginning, that's why you can understand. I am going to share with you all important things here only in this video tutorial. So what are basically theories of failures? There are basically 5 theories of failures are there. 5. So before going to share with you all theories of failure, let me share with you what is exactly theories of failure. What is failure basically? So basically, what happened, we did experiment with different types of materials, but here we are talking about only 2 types of materials: brittle and ductile materials and brittle materials. So basically, if you will get questions, MCQ questions, then definitely you would get a question which just I am going to share with you, that what type of material, for what type of material which theories of failure is recommended. So I will share with you right now, because first of all I have to share with you what are theories of failure. So first is maximum principal stress theory. Second, maximum principal strain theory. Third is maximum shear stress theory. Fourth is maximum strain energy theory, and fifth one is maximum shear strain energy theory. Okay, so this is all 5 types of 5 types of theories of failure, right? So now, most important, what type of material is recommended for what? So for brittle material it is just principal stress theory. For ductile material we recommend shear stress and strain energy theory. Okay, shear strain energy theory. So these two these two theories are most recommended for these type of materials. Now most important, one of the most important factor what I should share with you here only, all these theories having different names too. Just like for principal stress theory is known as Rankines theory. For principal strain theory is known as St. Sant Venant theory. Shear stress theory is known as Guest, G-U-E-S-T, Guest, and Tresca theory. Strain energy theory is known as Higgs, and another name of this Higgs theory is Beltrami. Higgs and Beltrami, right? And shear, this theory is having 3 names. One is here, one is distortion energy theory, and there are a few others name I should share with you, that is von Mises, and then Hanke theory, Hanke theory. So these are all theories of failures, right? So what till now I have shared with you 2 key points. What are other names of these theories of failures first, and what type of materials we used for what type of theories of failures. 2 things, 2 key points I have shared with you till now. Now we'll go through one by one, numerical point of view, what we should know. So we'll first start with maximum principal stress theory. First we'll start with maximum principal stress theory. Don't get diverted from this background music of background sound of pigeon. It's really amazing for me. Okay, so I cannot stop that pigeon to make noise. So maximum principal stress theory, what type of diagram basically we follow, that is rectangular. Why I'm sharing with you this diagram? Because this diagram already it's been asked. Okay, this should be like here only. Okay, that's okay, rectangular. So already this type of diagram already asked in GATE. That's why I'm sharing with you. So what type of diagram we must have in principal stress theory or Rankine theory, that is known as a rectangular. Okay, so one of the most important thing, another thing, what type of formula we must use? What type of formula we must use in case of principal stress theory to find out sigma 1 and sigma 2? Okay, so suppose that we have given sigma x and sigma y. So what type of formula we must follow for this? We need to understand that too, right? So what is that? That is sigma 1 and sigma 2 is equal to sigma x minus sigma y by 2 plus minus, what is about plus minus I will share with you, sigma x minus sigma y by 2 whole square plus tau xy whole square. The same formula we also used for Mohr circle. I have already shared with you a lot of things about Mohr circle. I hope you have enjoyed all those tutorials. Now sigma 1, if there would be sigma 1, then we have to write sigma x minus sigma y by 2 plus sigma x minus sigma y by 2 whole square plus tau xy whole square. And in case of sigma 2, sigma x minus sigma y by 2 minus sigma x minus sigma y by 2 whole square tau xy square. So this is how we can find out sigma 1 and sigma 2 for maximum principal stress theory or Rankine theory in case of theories of failure, right? So, and this theory is recommended for brittle material. This theory is recommended for brittle material. Remember, so there are 3 key points we need to remember: first, second, and third, and of course fourth number is here, another name of principal stress theory. So 4 key points to get success in these theories of failure, that is principal stress theory. Remember and enjoy, and hopefully you got question. Then you have to practice, because without practice you cannot remember all things together in your mind. So if you practice, you can easily remember, right? So let's go for the another theories of failure. Second, that is known as maximum principal, it's not principal, it's principal, maximum principal, okay, sorry, maximum principal, it's PL only, it's a principal strain, maximum principal strain theory, right? So this theory is also known as ST Venant's theory, right? And here, just like I have shared with you, diagram we need to know what type of diagram we are following. Graphical representation you can see also. In case of Sant Venant's theory, we are having a graphical representation, that is rhombus. And what type of is this? Like this only. So this is a rhombus, right? So this is one of the key point, and so first key point is here, another name. Second key point is here, it is known as rhombus. Now principal strain theory, what type of formula we have in case of principal strain theory? Probably you have gone through, or I don't know you have gone through or not, but let me share with you what kind of formula you must know in case of principal strain theory. Now this is here, sigma, it's sigma 1 by E minus sigma 2 by mu sigma 2 by E minus mu sigma 3 by E is equal to sigma, in case of tension, if you'll say elastic limit in case of tension. So what we got here, if you will take common of sigma 1 by E minus mu by E, if you take common, then sigma 2, it should be sigma 2 plus sigma 3 is equal to sigma elastic in tension. So actually we got what this is, principal strain theory. We got this one for tension. Now if we'll talk about in compression what we got, then just opposite of it, just like we'll get mu sigma 3 minus mu by E sigma 1 plus sigma 2 is equal to elastic limit in compression. So this is for principal strain theory, right? Now let's go for the another theories of failure. Okay, so yeah, so this theories of failure is known as maximum shear stress theory. So this is the third one, maximum shear stress theory. This theory is also known as Guest and Tresca, right? So in this theory what you have to remember, that is important. So I have already shared with you. First point you have to remember, just let me say it. Yeah, first point you have to remember, that is its another name is Guest and Tresca. And if you will go through the graphical representation of this theory, then it's like here only. So you just need to guess what is this theory all about. Just need to guess, right? So what is this? Hexagon. So how we can do graphical representation of the shear stress theory? That is hexagon. And you will be wonder to know the formula for this, for finding out, if we'll find out maximum shear stress, that is sigma 1 minus sigma 2 by 2. Now most important, if we are considering factor of safety, then what we have to do? Suppose that this is we are getting a sigma y here. Suppose that this is sigma y, right? So if you are considering factor of safety, then what we have to do? Sigma y is equal to, suppose, sigma 1 minus sigma 2. Okay, so it will become sigma y by 2. So factor safety will be taking then sigma y by FOS by 2. FOS means factor of safety. So most of the time we have seen question, they probably ask you the graphical representation from this shear stress theory. But if you're talking about this, from this we already use how to find out maximum shear stress, and we know also how to find out sigma 1 and sigma 2, right? So this is how you can find, you can use the one of the theories of failure, that is maximum shear stress theory, right? So we'll move to towards the next maximum strain energy theory. So fourth number is maximum strain energy theory. This is the fourth theories of failure, right? Let me use another pen. That's blue one is most interesting one. Yeah, blue one is quite good. So here, so maximum strain energy theory having another name, that is Higgs, and the next one is Beltrami, right? So about these two names, so what happened? First you need to remember the theories of failure name. Okay, that is obvious, you will remember. The second one is other name of this theory. So this is known as Higgs and Beltrami theory, right? Now the representation, graphical representation, the graphical representation for this theory is ellipse. So we represent this theory, the graphical representation is ellipse, right? And most important, how we can find out that value, that means maximum strain energy, that is also important. So how we can find out the maximum strain energy? By using the formula. So what is the formula for that? I'm just going to sharing with you. That's why it will be quite easier for you to understand too, and you can use that formula in numericals. Okay, so stay tuned and keep watching. Just I'm going to share with you. I'm kidding, I'm just sharing. Here is it, strain energy per unit volume. Okay, strain energy per unit volume, right? You can see in short SC per unit volume is equal to, if you're talking about 3 dimension, we are considering sigma 1, sigma 2 and sigma 3, then what is the value of it? We need to understand it. Okay, so little bit lengthy formula is here. 1 by 2e, 2e means Young's modulus or modulus of elasticity. Sigma 1 is square, sigma 2 is square, sigma 3 is square minus 2 mu. Mu means, you know that, right? So don't know? Okay, don't worry, mu is Poisson ratio. Sigma 1, don't get confused with the other friction and I mean FM, fluid mechanics, don't get confused there, right? But who knows, probably we'll talk about this is dynamic viscosity. It's not like that. Sigma 1, sigma 2, sigma 3 and sigma 3 is sigma 1. So this is the formula for finding out strain energy per unit volume in case of 3D. Now if you are talking about 2D, then what would be the formula? This is for 3D, right? 1 by 2e, sigma 1 is square plus sigma 2 is square minus 2 sigma 1 and sigma 2. So by using this formula you can find out strain energy per unit volume, and hope you have enjoyed this strain energy theory or Higgs and Beltrami theory. Now the last one is remaining. I'm just going to share with you last one, but before going to share with you last one, just think about 3 things only, 4 things here. First, 1, second, 3 for 3D and 4. These 4 things are most important, but if you're preparing for MCQ level question, then coming from this it is little bit difficult because it is little bit lengthy. If you're talking about gate, then it can come in only 2 marks, but if you're talking about 1 mark question, then this one is most important, graphical representation. Already they have asked in gate. Okay, so let's go for the another theories of failure, that is maximum shear strain energy, which is most recommended for one of the recommended, because maximum shear stress theory is also, I mean, that one is most recommended, but yes, you can use this and the which one I'm just going to share with you. Wait, let me share with you first. 5th number is maximum shear strain energy theory. Now we'll talk on this topic, right? So for 2 things I have already shared with you. First is, if you're talking about brittle material, then which one is most important? That is a maximum principal stress theory. And if you're talking about ductile material, then maximum shear strain energy theory and maximum stress theory is also important. So these theories play most important role, right? So so are you looking for this theory or not? I hope you wanted to learn this theory, right? So then what you are waiting for? Just let me share with you. This theory having 3 names, and other 2 names are here. One is von Mises Hanke, H-N-K-Y, Hanke theory, and another name is distortion energy theory. Alright, basically I have already shared with you question which came in gate, but definitely I will try to share with you in this video tutorial only that question. That's why it will be quite good and quite easier for you to understand how you can solve question related to this theories of failure. One is they already asked in gate from graphical, but that one is quite simpler, but I will share with you a question probably that has been related with more circle. I have already shared with you, but right now also I will share with you in this in this video tutorial only, right? So let's go for this von Mises distortion energy theory or distortion energy theory. Okay, so this is also you need to remember. Now if you are talking about graphical representation of shear strain energy theory, then here is it is an ellipse. The graphical representation of this theory is ellipse. Okay, so these are 2 things you need to remember from here, 1 and 2. The third one is formula, which formula just I am going to share with you in this video tutorial only. So if you're talking about this in 3D, so there are 2 things we have to do in 3D, and second is in 2D. So there are 2 formulas we can get in 2D as well as in 3D. Let me use another color pen, that's why I will not get bored, right? So here for 3D, what we can do exactly, let me share with you. For 3D we have to use three stresses, sigma 1, sigma 2 and sigma 3, right? So what we exactly finding out, maximum shear strain energy theory. The formula for this would be maximum shear strain energy theory, you can see, okay, strain energy theory, okay, set SET. Now 1 plus mu means Poisson ratio by 6e sigma 1 minus sigma 2 whole square, sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. Okay, this is for 3D. Now one thing we can do here, that is modification, simplification of this part, because we know from elastic constant relation, what we know exactly I am sharing with you, E is equal to 2g1 plus mu. So we got this here, this value here, this value we got here. So what we can do exactly, 1 by 2g, we just transferring this value 2g to this side, so 1 plus mu by E. So what we can do, for this value we can write this 1 by 2g. So this equation become, what this equation exactly become, I am sharing with you, 1 by 12g sigma 1 minus sigma 2 whole square, sigma 2 minus sigma 3 whole square, sigma 3 minus sigma 1 whole square. So this is for 3D. Now if we are talking about in 2D, what will happen, this is, that's just what we have to do, sigma 3 is equal to 0, we need to put in this equation only. Then what will happen, we get what will happen to this equation in case of 2 dimension. So we get the answer here only, that is 1 by 12 g sigma 1 minus sigma 2 whole square plus sigma 2 square plus sigma 1 square. After simplification, what we got, 1 by 12g sigma 1 square minus 2 sigma 1 sigma 2 plus sigma 2 square, because 2 sigma would be there, therefore 2 sigma 1 and 2 sigma 2 square. So this is how, so this is how you can do this. Now we can do another thing here, we can get common 2 from this here. So what will we get here after getting common, 1 by, so g would be here, yeah, 1 by 6g sigma 1 plus sigma 2 square minus sigma 1 sigma 2. So this is for 2D and this is for 3D. We can use these two formulas. So what we got here, this one is 3 and this one is 4. So we need to remember these 4 things in case of this maximum shear strain energy theory. I hope you understand the theories of failure concept. And yes, the next thing is the numerical, which has been asked in GATE. So definitely stay tuned and keep watching this video. You will learn that numerical, how to solve that numerical. Okay, so let's go for it. So I have to write that question first. So what we got, that question, in that question we got the homogeneous, and this question already asked, already I have shared with you one of my video tutorial in this YouTube channel only. So stress, maximum state of stress for a metal, I hope you can see, right, for a metal part undergoes plastic deformation, that is here, and the equation for this is 10 5 0 5 20 0 0 0 minus 10, right? Now where stress component values are in megapascal, we have to find out using von Mises Henke yield criterion. The value of estimation estimated, it's written, shear yield stress in megapascal. A is 49.41, B is 9.50, C is 16.07, and D is 28.52. So this is the question, and the most important factor is that this question has been, they have relate with Mohr circle too. Probably not Mohr circle exactly, you can say it's little bit related to that only. I mean, because they are using this concept, so we can easily get this concept from here only. So this equation play most important role. I mean, this matrix play most important role for solving this question, right? So first of all, we need to understand what are these values talking about. So basically, this is sigma s, this is sigma y, tau xy, this is tau xy, right? And this is sigma z is equal to sigma 3. We have to take this value at sigma 3. Now from that maximum principal stress theory, we can get that sigma 1 and sigma 2 is equal to sigma x sigma y by 2 plus minus root under sigma x minus sigma y by 2 square plus tau xy square. So sigma x is 10 minus 20 by 2. Okay, so sorry, sigma plus minus root under 10 minus 20 by 2 whole square plus tau xy, that means 5 square. So after solving, what we are going to get, that is important. Just let me share with you how much value exactly we are getting here. Yeah, so what exactly we are getting here, 10 plus 20 is equal to 30, 30 by 2 is equal to 15, plus minus 10 minus by 2 5, so 5 square plus 5 square, that means 15 plus minus root under 50. So that could be if sigma 1 is equal to 15 plus root under 50, and sigma 2 is equal to 15 minus root under 50. And if you're talking about root under 50, what is the value of root under 50? That is important, that is 7.07. So what we have to do, we have to add with 15 7.07, that is 22.07, that should be in megapascal, and so minus 15, if we'll do minus 15 and 15 minus answer, that is okay, so 7.92. I'm getting, just a second, 1 divided by 2, 15 minus answer, so 7.92 we getting here megapascal. So we got the values of sigma 1 and sigma 2, but we have to use this von Mises-Henke yield criterion, which I have already shared with you what is about that, and by using that formula, we can easily find out the value, I mean the value we require, that is sigma yield shear stress, right? So sigma ys, I must say that. So basically what we know, sigma ys is equal to sigma elastic limit E okay, yt yield tension in tension, so root 3. So we have to find out first that values, right? After finding out that values, we can easily find out the answer. So let's go for that formula, and which formula we require to find out sigma yt, right? So let's go for it. So yeah, that formula is most important, right? So that formula is here. So what we have to do, according to that formula, we have to find out sigma E, what we have given name sigma, actually I have to see this, sigma ys is equal to, we have to find out sigma yt by root 3. So for implementing this formula, we need to know what is sigma, suppose this is sigma yt, right? What is sigma yt? Yield value we have to find out. Its formula is 1 by 2 sigma 1 1 sigma 2 2 square, that means 1 to sigma 1 1 minus sigma 3 3 square, that means that one only, plus sigma 2 2 minus sigma 3 3 square, this is for yield. Okay, so 6 sigma 1 2 square plus sigma 2 3 square plus sigma 1 3 square. Now we have to see that values, and what is sigma 1 1. Basically this is sigma 1 1, this is okay, sigma 1 1, sigma 2 2, and sigma 3 3. This is sigma 1 2. So we have to put values according to this equation. half sigma 11 is what? 10 minus sigma 22 is what we got here? 20 square, and half is there, so half, we have to put this half in bracket. Okay, so sigma 11 minus sigma 33, so 11 is 10, so plus 10 square, sigma 22 minus sigma 33, so sigma 22 is here 20 plus 10 square plus 6 sigma 12, sigma 12 is 5 here. See, sigma 12, sigma 11, sigma 12, so it's 5 square. Sigma 23, 23, 21, 22, 23, 0. Sigma 13, sigma 13, sigma 11, sigma 12, sigma 13, 0. So after solving what we got here, just we have to see that. Okay, just I need a calculator to share with you what exactly we are getting. So 10 minus 20, 10 square, I hope you can see, plus 20 square plus 30 square is equal to 1400 plus 25 into 6, just a second, is equal to this much, by 2 is equal to this much. And if I'll do this, then how much values exactly we are getting? 27.83 megapascal. So this is the value for YT. Now we have to find out what is YS. So 27.83 by root under 3. So what is the answer? 27.83 divided by 1 divided by 2 is equal to 16.06. Now if you see the question options here, that is 16.06 megapascal, right? If you see the options here, which one is this one is the right answer. C is the right answer. So this is how you can solve question related to theories of failure. And of course I am sure you understand this question. And one most important thing, this is a lengthy video. I hope you enjoy the tutorial, and thanks for watching. Thank you very much, and hopefully this video will help you a lot in examination. Thank you very much. Bye bye. Good day.